Thanks. So, hello everyone. Here is the talk about the FASER Experience is with ACTS. So first, let me very briefly introduce the FASER. So FASER is a new detector to search for the long-lived particle, and here is it is in the forward direction of Atlas, about 500 meters away from IP1, and so the background level for this experiment is very low and dominated by the muons. Here is the plot for the FASER detector. So in front we have an emission detector to detect the neutrinos, and then it's followed by a magnet, but it's also used as decay volumes. And then we have about 3 track stations to extract the charged tracks. And so here is a typical signal we are looking for. What we are looking is the 2 charged tracks with opposite sign, and they should come from a common vortex, but this vortex could come from any place in the decay volume. So we do not have any beam constraint for the vortex. And also for the charged tracks, since the magnetic field is horizontal, so which means the charged tracks should be separated well in the vertical direction. So that's why we need a good spatial resolution in the vertical direction. And here, the top 2 plots shows the spatial resolution in one direction, which is also good. It's good. It's about 14 micrometer, and in another direction, it's not as good. It's not so good, so which is fine to us. And so to meet this demand, we find that the ICT modules from Atlas is a good option for us. So that's why we use the ICT modules from Atlas to build 3 tracking stations, and each station has 3 layers, you can see here. So that's basically the tracker we are using. And another thing I want to mention is the FASER new detector, which is in front of these trackers, and it's made by emulsion. And so the one thing we need from the tracking tracking part is that we need an extrapolator which can extrapolate backward. So then we can match the tracks with the tracks in FASER new detector. And that's the difference with other experiments. And so here is the general status of the FASER. We want to start data taking at the same time with run 3, which means the tracking, the offline tracking is very urgent for now. And here is the general status for our offline software framework. So we are using Calypso, which is adapted from the Atlas SINA. And for the unit data model, we are using the same with the SINA, except for the track EDM, and also the tracking. For the tracking part, we are using the ACTS. So here is the general status for our tracking with ACTS. So first, for the preparation, the space point formation and clusterization. So this part is migrated from SINA and is finished and validated. And for the services and tools, for example, the magnetic field and the conditions, the detect distribution, also migrated from SINA. And for the tracking geometry, we built it with the ACTS classes. And so the thing we're currently working on is the Kalman filter. We are trying to use the ACTS Kalman filter to do it. And after that, we will work on the vortex finder, and the plan is that to use the vortex finder from ACTS, but of course we need to optimize it. So here is some details for the packages. So for this tracking preparation, it's for example the clusterization or space point formation, where we just migrated from SINA, and all of them are validated. So which means we are ready to do the real tracking. And here is the result from the tracking geometry. So we build the tracking geometry with the ACTS Q-board volume, which is different with other experiment. Because our station is made by ICT, by 8 ICT modules, so we can now use the cylinder volume. And when we build the tracking geometry, we basically retrieve the detect element from the detect store. And the one thing I want to mention is that I think it will be much simpler if we have a geo model interface to build the tracking geometry. So here is the extrapolator and track seeding. So for the extrapolator, we build it based on the ACTS propagator, of course with the FASER magnetic field service. And this part is finished, and we are currently working on the validation. And for the track seeding, we didn't use the ACTS track seed finder. We are using a simple track seeding algorithm from the ATAS trigger system. And this part is working, and we're supposed to have it very soon. So this one is a short summary for our FASER experience. So basically, the preparation for the tracking is done, including the conditions, the services, and also the EDMs. And for the tracking with ACTS, mainly it's currently we are working on is the Kalman filter. And so we plan to use the same track EDM with ACTS, but of course we need a converter for the EDMs between the Calypso and the ACTS. And in future, we plan to also work on the Vertex Finder. But for this part, we have different, since we have different detectors, so I would like to discuss this part. So first is for our detector, we do not have any beam constraint. So from the user point of view, we expect a Vertex Finder which can work without any constraint. And another thing we would like to discuss is the propagator. So since we have a FASER new detector in front of the tracker, so we need to match the tracks. So we need to propagate backward, not forward, for the tracks. So these two parts are the things which we have difference with other experiment, and it's good that we can discuss. Okay, that's all from my side.
Great, thanks a lot. Any questions or comments or answers even?
I have a question again. Sorry, I'm not raising my hand.
That's sure. Go ahead, John.
Okay, thank you. So earlier you were talking about the interface tracker between FASER and FASER new. Mm-hmm. And from the diagram, it looks almost exactly like the looks almost exactly like the tracking stations. So is the interface tracker just effectively a fourth tracking station, or is there a qualitative difference I'm missing?
It's not decided yet, but if we have it, it should be the same with the track station.
Right, and so we just do track matching using that between FASER and new.
Yeah.
Okay, thank you.
Other comments?
Yeah, of course. One comment. Of course, you can back propagate. Yeah, that should not be a problem. Of course, wherever you want to go, you need to define this in an ACTS tracking geometry volume.
Yeah.
Yeah.
Maybe a comment from my side on the question you had regarding the vertexing, on whether you can use the ACTS vertexing also without a beam constraint. So yes, you can. So you can use it with and without beam constraint. And tomorrow in the tutorial session, I'll be showing how to set up a vertex finder using no beam constraint. So that's probably exactly what you want to do. I mean, probably you don't want to use the adaptive multi-vertex finder that I'll be showing, but in any case, you can use it without a beam constraint.
Yeah. Okay, that would be great. Thanks.
Yeah.
I see Solda has a question.
Yes, hello. Yeah, concerning this issue of the vertexing, okay, maybe the cartoon is too simplistic, but on page 4, when you see that the two tracks, they come almost parallel. So, okay, then probably you can do some vertexing in, let's say, in the transverse direction, but not in the longitudinal, right?
Sorry, may you repeat again? My connection is not good.
No, what I will say is that as the two tracks look very parallel, I don't know, maybe this is the cartoon is too simplistic, but
yeah, they are very kind of parallel.
Yeah. No, so I mean that there is no way you can find, let's say, the vertex in the in the.
Oh, I lost your voice, I think.
It wasn't you. It was Salva. Salva cut out. He was, but he was. I guess you heard his point.
I mean, can you hear me?
Yeah, I can hear you now.
Yeah,
No,
we
okay,
heard
well,
you mostly, Salva. We just lost the last piece of what you said.
Okay, sorry. No, I was saying that, I mean, if the vertexing works well along the track direction, that's I mean, which resolution do you expect there? Or maybe this question is a bit too out of scope.
Maybe someone wants to answer it. I see Dave has his hand up. I'm not sure if he wants to answer it or ask another question.
Well, I just wanted to say that for the dark photon signal, we don't really care exactly where the decay vertex is, but we would like to, if possible, we'd like to be able to say that it came from within the tracking, the decay volume rather than at the veto. So for the longitudinal resolution, it doesn't have to be extremely good. For the matching of tracks to FASER new, the tracks won't be parallel like this. So
that part, yes.
In that case, we have a more favorable vertexing scenario.
I mean, these are dipole magnets, aren't they? I mean, what's the field?
It's 0.6 Tesla.
There's another comment question from Dave. I think
he just spoke, Andy.
Sorry.
Okay.